Hello students, we'll continue with our motion in two dimensions. We have already seen oblique projectile, we have seen equation of trajectory, we have seen horizontal projectile. Now in this video we'll see projectile from a height, and of course the next one would be relative motion. When a projectile is projected from a certain height in upward direction here, of course if you have to go for downward direction, only the sign changes, everything else remains same. Then I can't use the formulae that I have derived for the projectile motion. Those formulae are only applicable when initial and final points of the projectile are at same altitude or same height. So here let's see, if this is V, then this side, this would be horizontal component would be V cos alpha, and vertical component would be V sin alpha. This is V sin alpha. So I want to find time of flight. What is delta y? Delta y, because h is downwards, I mean the final position is below the initial position, I'll take it as negative. Acceleration in y direction, we all know it is minus g. And what is initial velocity? Initial velocity in y direction is v sin alpha. So let's solve it. What will I get? I'll use delta y equal to uyt plus half ayt square. So from this I'll get delta y is how much? I'll substitute it, minus h equal to, I'll have v sin alpha into t plus half into minus g into t square. This is what we have. So from this I can write minus h equal to v sin alpha t minus half gt square. So this is what we have. Now let's find an expression for time from this. So our expression is minus h equal to v sin alpha into t minus half gt square. So let me convert it into a quadratic equation with the coefficient of t squared to be 1. In that case, what will happen? I'll write it as gt square by 2 minus v sine alpha into t minus h equal to 0, or we can write it as t square minus 2v sine alpha by g into t minus 2h by g equal to 0. Now t equal to minus b plus or minus root over b square minus 4ac. We'll use that expression. So that will give me 2v sine alpha by g plus or minus root over b square is 2v sine alpha by g whole square plus or minus not plus on b square root of b square minus 4ac. So because there is a negative sign here, this will become plus 4a is 1, c is 2h by g. I'll write it as 8h by g by 2. So this is the expression for time. So I'll choose the value which is non-negative in this particular case. So one would be negative and the other one would be positive. The positive number or value of time will give me the time of flight. And I don't expect the students to remember this formula. You can directly put the equation and solve it there itself. You'll get the answer for this question. So this is what is the expression for time of flight. Next, let's try to find out range. So range is always found in the same way. So because horizontal velocity is constant, this is range. In fact, it is from this point to this point. This whole is range. Now we know horizontal velocity is constant. So I can say once I found time of flight, then range is simply horizontal velocity into time of flight. So the time of flight is something that we have found in the previous one. So again, the same old things, like if I want to find final velocity, once I know time, everything else becomes pretty simple. So final vertical velocity would be how much? It will be v sine alpha minus gt. So what will be the net speed? Vx, as we say, it is v cos alpha, it is always constant. Net speed with which the object strikes ground would be vy square plus vx square. And of course, if I want to find angle at which it strikes ground, it will be vy by vx. Everything else is same. Only thing is I have to find time, right? So some people, what they do is they do it in two parts. They first find out what is the time taken to go up and then the time taken to come down. That's also correct, but that's a longer way of arriving at the answer. So because we are calculating displacement, I don't have to bother about the intermediate positions. What I'm bothered is only initial position and final position. Hope you could follow what we have done. So that is what we have in projectile motion when it is projected from a certain height. And as I told you already, If it is projected downwards, everything remains same, only the direction of initial velocity changes. Thank you very much.